If you have ever tried to walk along a railway track, you notice one thing immediately. It is extremely hard to walk on. The stones under your feet are sharp, loose, and unstable. Every step feels uncertain, as if you are walking across rubble rather than a trillion-dollar piece of infrastructure. It is precisely these loose, unbound stones that allow a massive mass of up to 10,000 tons of steel to float stably. And that is the key truth. A railway does not need a smooth surface for humans, it needs something that can carry millions of tons of steel while still preserving accuracy down to the millimeter. And one important warning: because of that very irregularity, you should never step down into the track ballast area to take photos or use it as a shortcut. Research shows that this surface impairs human balance far more seriously than flat ground. It was designed for trains, not for you. So the real question is this: why is such a heavy, modern system not locked rigidly into concrete? Why is it resting on what looks like a temporary pile of broken stone? Welcome to Everyday Things Explained. The track is not designed to be perfectly rigid. Our instinct always tells us this: the heavier something is, the more firmly it must be fixed to the ground. But railways are a different kind of problem. Think of this structure like a layered cake: steel rails on top, sleepers in the middle, and a thick layer of ballast stone underneath. The first job of the stone is to distribute the load. Instead of letting enormous pressure concentrate at one point and crush the soil below, this layer spreads the force across a wider surface. But the truth is, a railway does not succeed because of absolute rigidity. It succeeds because it preserves track geometry. It must be flexible enough to absorb vibration, but also stable enough not to drift out of alignment. That is why this stone layer is a kind of living foundation. Machines like the tamper and the ballast regulator periodically redistribute and compact the stone to maintain that geometry. That is something concrete can never do with the same level of flexibility. The stones hold the geometry of the entire line. So if the goal were only to support weight, why not use smooth round pebbles and make it look nicer? The answer is friction. Round pebbles would roll over one another under vibration, and the whole track would begin to shift as if it was standing on marbles. Standard ballast has to be crushed stone with sharp edges, creating enormous friction to resist the sideways forces that appear when a train takes a curve. This is what allows a 10,000-ton train to glide smoothly over millions of stones that know how to move in the right amount. But the real enemy of the railway is not just weight. It is water. The real enemy is water, mud, and roots. If water is allowed to collect, the soil underneath turns into mud, and the entire structure begins to lose stability. This layer of stone is actually a giant drainage system. Rainwater passes immediately through the gaps between the stones, keeping the ground below dry and firm. This is the railway's silent bodyguard. And there is another common misunderstanding. People think the stones are there to kill weeds. The railway industry still has to manage vegetation actively throughout the year, because if grass and plants grow too densely, they fill the gaps between the stones. By this point, you can probably see that these stones are not random at all. They are a true work of engineering. But then, why do we call them ballast? Ballast, an old word for a solution that still has not gone out of date. The word originally came from the SEA. In earlier centuries, sailing ships without cargo were too light and too easy to tip over. So sailors filled the hull with stones to create stabilizing weight. That same logic was later borrowed by the railway. Use heavy material to create stability. It was a smart inheritance, carried from the ocean onto land. So why, after more than 200 years, do we still use it? Because it solves too many problems at once. It carries load, it drains water, it can be packed, adjusted, and restored. And it does all of that at extremely low cost. It is a perfect example of industrial inertia. A solution does not need to look elegant. It only needs to work better than anything else inside an entire system of materials, machines, and maintenance. So the next time you look down at a railway track, what you see will no longer be just broken stone. It is a foundation deliberately made to look rough, sharp, and messy, because for railways, that is what stability looks like. But why do railway rails almost always have an eye-shaped profile instead of being solid blocks of steel? The answer lies in a surprising rule of physics, which we will explore in the next video. Thank you for following Everyday Things Explained. Do not forget to press like and subscribe so we can keep understanding the world around us more clearly. See you next time.